For our first example of calculating efficiency, let's look at a ramp, more formally known as an inclined plane. We can do the ideal mechanical advantage simply by saying we are going to push it up 12 meters of ramp to lift it a height of 2 meters of ramp, which is a mechanical advantage of 6. But the actual mechanical advantage would be how much we need to lift, 783 newtons, divided by how much force it's going to take us, which is 150 newtons. This, on a calculator, is 5.22. So the mechanical advantage could be as good as 6, but because nothing in the world is 100% efficient, it's less than 6. Turns out to be 5.22. So how exactly efficient is this ramp? So for efficiency, we're going to do 5.22 divided by the best possible of 6, and that comes out on a calculator to be 0.87. Efficiency is usually spoken of in terms of percentages, so we would say that this ramp has an efficiency of 87%. Now that 13% loss is something like friction, probably not moving fast enough for air resistance to be an issue. So nothing is 100% efficient. This particular ramp is 87% efficient. For our second example of calculating efficiency, let's look at a lever. In this lever, the ideal mechanical advantage is the push distance, 5.8 meters, push length rather, over the lift length, which is 6.3 meters, which comes out to be about 0.921. The actual mechanical advantage would be the the weight being lifted, so 45 newtons, divided by the force required to do the lifting, 57.7 newtons, which comes out to be about 0.780. Now we can calculate efficiency. Efficiency is the question of what part of what is possible actually gets used. Well, the best thing we could possibly do is a mechanical advantage of 0.921, but we actually had a mechanical advantage of 0.780, and that comes out to be approximately 0.847. So the efficiency of this particular lever is about 84.7%. In our third and final example, let's look at a block and tackle system. This particular block and tackle system is made up of 5 pulleys. Notice on the left that this has a downward pulling rope or a last rope over the top. Remember, we don't count that one, so we have an ideal mechanical advantage of 5 since there are 5 loaded ropes. The actual mechanical advantage, we have 100 newtons being lifted with a force of 22 newtons, which is 4.545454 repeating. So our efficiency is that 4.54 repeating divided by the best possible, which is 5, which comes out to be 0.909090 repeating for an efficiency of approximately 91%.